My name is Davi Costa, and I will summarize my poster on non-invertible symmetries in finite group gauge theories. It is based on two works that I have with Clay Cordova and Po Shen Xin, and and you should check the papers if you want more detail. Uh, okay, so the poster is divided in three parts. So, and each part corresponds to a column of the poster. The first column is a review part. The second column is based on the first work, and the third column is based on the second work with Clay and Pochen. In the review part, I will start by reminding ourselves that global symmetries are intrinsically defined by topological operators in quantum field theory. I will explain their symmetry action on other operators and their fusion rules. I will then move to finite group gauge theories. I will outline some motivations for studying them, and I will explain how they can be defined on the lattice. So this is the review part. The second column is the one which is based on my first work with Clay and Poche. In this column, in this part, I will outline how we can construct domain walls in finite group gauge theories using the folding trick and a classification of gap boundaries in finite group gauge theories. Uh, this is a very explicit definition, and we can use it to compute some fusion rules of the domain walls, as well as their action on other operators. And I will try to outline this type of derivations. A highlight of this part, like the second column, is the identification of a non-invertible generalization of electric magnetic duality. We will see that in our setup, this electric magnetic duality domain walls corresponds to the non-factorized twisted domain walls. Okay, so now moving to the third column, which is based on the second work with Clay and Pochen. In this part, I will try to explain to you how the domain walls that we construct explicit on the lattice, how they are in fact condensation defects. By that, what I mean is that they are made out of lower dimensional topological operators. Specifically, they are made out of Wilson lines and magnetic defects. I will explain how the data that labels the domain walls is related with the data that labels the condensation defects. And there is like a non-trivial dictionary between the two. A highlight of this part of the paper is explicit, the paper and like the poster that I that is in the poster is an explicit derivation of the action for D4 gauge theory that can be obtained by gauging a swap symmetry of Z2 cross Z2. And like very important in this derivation is the explicit condensation expression for this swap symmetry. So it uses all the previous results. And that's the summary of my poster. I'm very excited to see you all in strings, and thank you very much.